Welcome back, everybody. I'm going to continue to show features of the AbLead Antibody Analysis and Engineering Suite in the example entry. And again, this is a view for rank order analysis showing features of each entry across the project that derives a scoring function for rank order analysis. It also allows for analyses of bulk and individual entries in the project. I'm going to show one called liabilities. So we'll select everything in this entry. 15 isn't too many to show at once. So if you were doing engineering of a single lead, you would of course select one, unless you wanted to compare it. I showed alignment and cladding in the last video. Go back and watch that if you missed it. We'll select the liabilities tool here. And the tool looks at all of the entries that were selected. You can see here 1 through 15. It looks at all of the regions by default. I could narrow that down to just a single region or back to all of them. It looks at all of the liabilities that were found for the selected set of entries. If a liability is not found, it won't be shown here. This allows you to screen through and see which specific liabilities you'd like to show, or all of them. The AbLang language model cutoff for AbLang and AbLang 2, I've set to 3 in the framework positions. Or actually, it's all positions, depending on where they are, but you can change that. You set it higher if violations are going to be shown. This is the difference between the parental and the most optimal position or residue at that position. For example, here the parental is an aspartic acid. It should be an alanine, the language model thinks, in the context of that sequence, at a difference of 5.3, which is a pretty strong difference. I'll leave this set to 3 for illustration purposes. There's some coloring shown down here, the ABHAN coloring, region coloring, and also the violation severity colors. If you select an entry and don't hide blank, it'll show everything. But if you hide the blank entries, it only shows those that have that feature, that liability. If you click on any one of the columns, it's a toggle for a structure view for that entry. And so, for example, this has a cysteine. This example 2 has a cysteine here. So I'd like to see what it looks like in the structure. So I'll come up here and click example 2, and it opens a mole star view. And I can drag this bigger if I'd like, move this around, zoom in, rotate it, move it around. And I would zoom in and look at this and say this cis and this cis, there's 2 free cysteines in this molecule, but these cysteines most likely are not forming a disulfide. And so example 2 will need to either have these cysteines edited for developability, or throw this entry out as a possible solution to the lead selection. So if I scroll down, I might want to look at this and edit this. I don't know what this cysteine should be, but let's say I decided I just wanted to make it a serine. I could click on this residue and it opens an engineering modal. I could name this as a group. You don't have to name a group, but it helps in the engineering panel to be able to see engineering positions that are grouped together. I don't know if this is going to impact efficacy, so I'm going to include the parental residue, and I'll just make that a serine. And I'll show you what this looks like in the engineering panel and in the positional frequency analysis tool. So I'll save that mutation, and you can see when I did, it gets a dot here. That's mauve for mutation. This is ochre for an observation. I'll click on this residue and show you. If you see an observation dot, you can click on it and say, oh, in a previous molecule, I saw this methionine and it was indeed oxidized. And so you can quickly see from past experience whether specific positions have an issue. This has a second cysteine, so I'm going to scroll down to that. And in this case, it has 2 entries because one is an AbLang violation and one is the unusual cysteine. I could click on either one. It thinks it should be a W. It's in a CDR, so who knows? We'll look at it in positional frequency analysis. But for now, I'm going to click on this. I'm going to give it the same group as cis, and I'm going to give that a serine. And you could put in comments if you'd like. I'm going to include the parental because, again, this might impact efficacy. And I'll save that mutation, and there's its dot. And then it showed up on both cells. You can export this as a grid. You can also export this as a set of SVL files for labeling in the molecular operating environment by the chemical computing group. So you load your molecule, you execute this SVL file, it colors the regions, it displays the residues, it colors the residues, and it builds selection sets within Mo for whatever happens to be showing in the grid at the time. So if I were to just change it to fragmentation, both of these exports would just reflect what is seen on the screen. And you can see in this molecule, it's not even up here, molecule 2, because it doesn't have any fragmentation, but I'll click 4, and there's its fragmentation site. So let's jump over to positional frequency analysis because we made a couple of mutations. I made them on example 2. So we'll jump into that. I'll show humanness later. And here's a positional frequency analysis of those positions. It shows the entire light chain and the entire heavy chain in one long row, and I'm showing the liability that occurs at residue positions. Some of them might be multiple liabilities, and it's just showing one of them. There's an unusual cysteine, and down here, I don't see any that are alternately colored, but that has AbLead violations. There's that cysteine that we were worried about earlier, and you can see that it has that same grouping. This engineering panel floats and sees the same information across tools, analysis tools, and so there's that free cysteine. If I were to look at that cysteine, it's in a CDR, and so the AbLead probability is showing it in cis, and I don't have any germline information, positional frequency, not germline, observed antibody space information because this is in a join region, and so there's not enough statistics to show here. But let's find that other cysteine. I've forgotten where it was. Let's screen along, and it's right here. And that should be a tryptophan. It's in CDR3, but it's off at the edge of CDR3. And so let's click open this AbLead probability, and I'm going to click here to toggle on that column selector, and I'll click on this tryptophan, and I'll click on this cysteine, and AbLead has a pretty strong violation difference, calling that a tryptophan. And on top of that, I'll collapse this. The germline, the closest germline is IGH4-4, and I have 1.7 million representatives of that germline. And across that germline set in the observed antibody space, 96.8% of the time that position is a tryptophan, and only 0.9% of the time is that position a cysteine. So I might make the decision that I want to change that to a tryptophan, or maybe keep it a serine and a tryptophan. And again, I'll keep it as parental because it may impact efficacy by making that modification. So there's how to couple the liability with a positional frequency analysis. But now let's go in and see what that's done in the engineering panel. You can see that it's tracked those engineering positions. I can drag this over to see if I had any notes or any information here. I can select these, export that as a grid, and it would just export this grid. But I can generate the combinations with or without the parental residue. So I'll generate them with the parental residue. It'll build all combinations of those entries. I had 2 entries here, so S with W, S with S, S with parent, parent with W, parent with S, and then of course the parent is no mutation. It has tracked these, it's built these as variants. I could select individuals that I want to make or select all of them. I could export this as a grid for my notebook or for a report. I could build these as just FASTA files and it would go to the parent sequence, make these mutations and export them as FASTA for use in another program or to send off to be produced. This alone saves so much headache in human error in making modifications to positions and building combinatorial variants. But if I click build selected, it will make those mutations, keep them inside the system, build out these combinatorial variants, run all of the analyses of these combinatorial variants, and populate them back into the main grid. This will only take a moment. It's almost done. There it is. I'll return to the tool. And then these yellow dots mean there's been a change to the main grid. So you may want to go back and revisit these tabs. That's all it's telling you. There are the new entries. And if I sort by name, it'll couple them with example 2. And we can go over to the score and see that it has had a profound impact on the score because we have modified the cysteine positions from the parent. The surface properties is showing not calculated because I haven't uploaded a PDB file, but if I wanted to generate those, I could and upload them here, and then the surface properties would be calculated and added to the score. And that should be done. You can see that I only did this for one of them. The combinatorial variant production didn't produce a mutation in all of these positions. And you can see that here, that some of them maintain the parent cysteine. And that's why that cysteine is showing. In reality, I would not do that. I would not include the parental cysteine because one cysteine wouldn't be something that I would take forward as a lead. I was just demonstrating the ability to do combinatorial variants and liability evaluation. So I hope that was informative and look forward to seeing you in the next video.